Chemistry. We're continuing the answers video for day 27-28 on molar mass, and we're moving on to page 5, which is glucose. Alright, so the table's already been filled in. Let's go over it. So glucose has carbon, hydrogen, oxygen to form this molecule, a glucose molecule. It's 6 carbons, 12 hydrogens, 6 oxygens. So the mass, the atomic mass, is going to be 6 times 12.01 from your periodic table is 72.06. 12 times 1.01 for hydrogen, that's also from your periodic table, 1.01 is 12.12. And 6 times 16 from your periodic table is 96 AMU. You add all those up and you get 180.18 atomic mass units for the mass of a single glucose molecule. Number of moles, you're simply now over here multiplying everything by 6.022 times 10 to the 23rd. So you go from 6 atoms to 6 moles, 12 atoms to 12 moles, 6 atoms to 6 moles, and 1 molecule to 1 mole of molecules. The molar mass is simply going to be the atomic mass, same number, but you change it to grams. Grams, 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 same number. And for the number of atoms, it's simply 6 moles, so 6 times a mole is 6 times 6.022 times 10 to the 23rd, 12 times 6.022 times 10 to the 23rd, and 6 times 6.022 times 10 to the 23rd, and then it makes a single glucose molecule, so it's 1 times 6.022 times 10 to the 23rd molecules. These are all atoms. This one is a molecule. Alright, so now we're ready to answer the questions. We'll go ahead and do this. So it says fructose. They have the same formula actually. I believe they do. I could be wrong in that, but it doesn't matter. We're talking about glucose, so let's just go ahead and make that change. It's really not important. Doesn't want you to think I'm changing molecules on you here. So how many glucose molecules in 3.1 moles of C6H12O6? And I told you, instead of writing that every time, you can just write GLU, G-L-U, for glucose. It just makes it a little shorter. Okay? So in 1 mole of glucose, you have 6.022 times 10 to the 23rd. So in 3.1 moles of glucose, you have 3.1 times 6.022 times 10 to the 23rd. Okay, so there are 3.1 times 6.022 times 10 to the 23rd. You don't have to actually do the multiplication there. I told you that before. Molecules of glucose in 3.1 moles of glucose. So that's your answer there. How many grams is 4.5 moles of glucose? So 1 mole of glucose is 180.18. So 4.5 moles would be 4.5 times 180.18. And this one you do actually do the calculation. Okay. So there's 4.5 times 180. That gives you this number right here, 810.18 grams of glucose in 4.5 moles of glucose. All right, number 3, keep moving on. How many moles of carbon in 2.2 moles of glucose? So in 1 mole of glucose, there's 6 moles of carbon. So if you want 2.2 moles of glucose, you need 2.2 times 6 moles of carbon. Okay, so there's 2.2 times 6 up there, 6 moles of carbon. You want 2.2 moles of that. 2.2 times 6 is 13.2 moles of carbon in 2.2 moles of glucose. How many grams of hydrogen in 1.6 moles of glucose? So in 1 mole of glucose, we come to hydrogen, come to the hydrogen row and the molar mass. That's what we're talking about. So it's 12.12 grams in 1 mole. So in 1.6 moles, it's going to be 1.6 times 12.12. Okay, so there are 1.6 times 12.2. 1 mole is 12.12. 1.6 moles is going to be 1.6 times 12.12, and that's 19.39 grams of hydrogen in 1.6 moles of glucose. All right, a couple more to do. How many oxygen atoms in 2.5 moles of glucose? So in 1 mole of glucose, you have to come over to the atoms, the oxygen row, and the atoms are 6 times 6.022 times 10 to the 23rd. That's a mole. There's 6 moles. And they want to know about 2.5 moles. So if this is 2.5, you have to multiply this whole term here, all of these numbers, by 2.5. Okay. So again, in 1 mole, there's 6 times 6.22 times 10 to the 23rd. So in 2.5 moles, there's 2.5 times 6 times 6.022 times 10 to the 23rd. So that's what you see right here. You don't have to do all that calculation. And that's atoms of oxygen in 1.6 moles of glucose. All right, and how many grams of hydrogen in 4.4 moles of glucose? So, for some reason I asked you a second question about grams of hydrogen. Anyway, let's just go ahead and do it. So in 1 mole of glucose, there's 12.12 grams of hydrogen. So in 4.4 moles of glucose, there's 4.4 times 12.12 grams of hydrogen. So let's go ahead and finish that one up. Okay, so there's 4.4 times 12.12 grams hydrogen, which equals 53.3 grams of hydrogen in 4.4 moles of glucose. All right, so that takes care of this one for glucose. Move on to the next page, page 6. That is a problem I'm going to leave entirely for you to do. That's really the one, this is the one I'm really going to check. Now, even though I'm not going to do this one in the video and we didn't do it in class, if you want to come to me in tutoring on Monday, I'd be happy to work through these with you, okay? So if you feel like you need that additional support to do it. Otherwise, just go ahead and do it on your own. And now I'll do a few from the last page here, which are the same ones we did in class. Okay. What is the significance of molar mass? We really answered that. I think that was a leftover question from another year, another semester. So we already answered that. All right, so we're going to do the first 3, the same 3 we did in class. So here we go. Down here I can do the calculations. We bring our periodic table. Bromine is one of the halogens, second to last column, 79.90. Okay, so the molar mass, so it's the addition of those two, and we're talking moles now. We're not worried about atomic mass units and molecules. We're talking moles now. So the way you write the molar mass is simply 80.91 grams per mole. It means that many grams of bromine for every 1 mole of bromine. So that's what the equivalency is going to be. You can write it in either order, either one first. I usually write moles first. Okay, so unit of measure and the substance, unit of measure and the substance. The shorthand is, you don't have to write all the words. That's really it, actually, over there. The molar mass is really just 80.91 grams. Now the shorthand is, it's 80.91. If you wrote it in both places, that's fine. Grams per mole. And again, what that means is 80.91 grams of bromine for every 1 mole of bromine. Really what the equivalency says very explicitly. Now the conversion factors, and these are important because you're going to use these in chemical equations coming up in the next week, is this one over this one, and then this one over this one. Doesn't matter which order you do that in. So it's 1 mole. And I usually put the word or. You can put an equal sign there because they are equal. You're going to choose one of these when you get to plugging them into a chemical equation. And you'll see what that means, okay? It may mean nothing to you now, but you'll see what that means next week. Okay, so there you go for bromine. We'll do ammonia. So that's the molar mass. Let me get on screen here. That's the molar mass of ammonia. So we come up here and we're just going to write it up here. The equivalency, the shorthand, and the 2 conversions. Okay, there you go. So you'll see with the significance of these coming up shortly. Okay, one more. Go down here. Sulfur tetroxide, and I don't know sulfur off the top of my head, so I come over here, 32.07. Okay, there's the molar mass of 1 mole of sulfur tetroxide. So now we've come up and finish this off. Again, conversion factors are simply one of the equivalencies over the other, and then you flip it over this one. Okay, and that's how you do those. Okay, that takes care of it. I'm going to be checking these two. I'm going to leave those two for you to do entirely on your own, and that takes care of all of the answers videos for days 27, 28 molar mass, and we'll see you on the next lesson.